So last video here, and what we're going to do is we're going to actually look at our value that we got, find a critical value, and make all of our conclusions. So I'm going to go back to my table here that I've been working in, and what I'm going to do is I'm going to put some stuff here. Get ready to chart. These are from something else. I'll have a video on how to make some charts in case you need them coming up there. All right, so I'm going to just go in this cell right here. I'm just going to organize this. I'm going to put null hypothesis. I'm going to say, so here it's gender and pairs of shoes. Remember, the null hypothesis is always that they're independent. So gender and number of pairs of shoes owned are independent. The next column I'm going to put alternate. Next column, next cell, alternate. Gender and number of pairs of shoes are independent. Okay, then I need my degrees of freedom. I need to know what that is. So degrees of freedom equals rows minus 1 times columns minus 1, which equals 2 minus 1, which equals 2 for me. All right, my degrees of freedom is 2. Yours might be different. So then what I want is I want my chi-squared critical value. So my critical value, 2 degrees of freedom and 5% significance level. And just so we're on the same page, use 5% significance level to get your chi-squared critical value. And then if your value is really close to the critical value, so if you did like a 1% significance level, then it would change. And I'm sure we'll get that in a second, but maybe we'll look at it from a couple of different ways. But for right now, to start with degrees of freedom significance level. In your OneNote, I put a page right here that you have someplace else also that says chi-squared critical value. This is a table. So my degrees of freedom are 2, and I'm doing 5%, so that's 0.95. That's how many less than 100. Significance level. So my critical value is 5.991, and you can see 10% significance level. It's there. That's 2.5%. This is 1%. This is 0.01%. So you can see the difference there with the significance levels. So I'm just going to stick with this one, 5.991. So that's my critical value. So I'm going to go back here. I'm going to write is 5.991. All right, that's my critical value. Again, you can see that my value is tiny. I'm not going to have a difference using any of those numbers. It's going to be the same result every single time. So then I'm going to put down what my conclusion is here. All right, my chi-squared value is 0.319 whatever. My critical value is 5.991. So my value is way under. All right, and remember, if your chi-squared value is under the critical value, you accept the null hypothesis. So I'm just going to put this down. Now this is just notes for me to put into my paper. I'm going to put down since the chi-square calculated is less than chi-square critical, I accept the null hypothesis. And that will go in my conclusion when I'm finishing up this paper, or in there someplace, so that it says this is what I found, so this is what actually happens. All right, so be careful when you're doing this stuff. Take a look at it. You want to be very sure that we have the right number. And again, let's say this came out to be 6.25. All right, if I go back to my table here, 6.25 would be accepted at 5%. But rejected at 1%. And maybe I want to say that, talk about what that means, and just kind of say that it makes a difference at what significance level I'm looking at with this, because it will be accepted at certain significance levels and rejected at other ones. It's something that I can look at and talk about in terms of my reflection and my personal engagement in my paper. So at this point, your math is done. Now we just need to do a really, really good job of organizing all of this and putting it into our actual paper.